I'm gonna make a quick video for you guys about the force of friction, or FF, and hopefully you guys saw the FF equals mu Fn. And these two, the Fn and the F of F, they should be familiar to you. A real quick thing to consider about this is you might notice that this has the unit of newtons. We don't know what the unit of this is, and this has the unit of newtons. In fact, this value, this mu, is called the coefficient of friction. And anytime you see coefficient of anything, think no unit. Let's take a look. If you have newtons times something equals newtons, this is just going to have to be something basic like 1. And basically it's just saying it doesn't have a unit. Okay. Now, these are two important things. So the Fn, that's the normal force. Now, that's basically how much the surface pushes on, the two surfaces push on each other. Think of this, if this was like a big object, like a block, and let's say you put an even heavier block on top of it. So here's another block, it's super heavy. So if you put this on top of this other block, now you've got two blocks on top of them. It's going to be heavy now, and it's going to be harder to push. In fact, the ground, it's going to be harder to push sliding across the ground. That is going to slow this object down. So that's pretty interesting, guys, that the heavier an object is, or the more, not quite the heavier, but the more the surface, the forces, the two surfaces exert on each other, the greater the force of friction. So let me write that down. The greater the forces to surfaces exert, hope I spelled exert right, so the greater the forces the two surfaces exert on each other, the greater the force of friction. So remember, guys, for every force there's an equal but opposite force. So when we have these two objects right here, they're going to push this surface down. But remember, this surface also pushes up as well, because for every action there's an equal but opposite reaction. So we have these two forces. Now this one is known as the normal force, and this one is the product of the normal force, and it's pushing down the surface. This is why, you know, when you put a book on top of a desk, it can provide this force, and it can also sustain this force. When you put a really heavy book on a piece of paper, it can't really provide this force, nor can it sustain this force, and the heavy book will break through the piece of paper. Okay, but let's go back. All the way back to the very, very beginning. Now, what is mu? Mu is something that a lot of people might be confused about. We've only basically talked about it minimally. Mu, an important thing, guys, mu is determined by whatever this surface is made out of, and then, in fact, whatever this surface is made out of. It requires knowing what both surfaces is to look it up on a table. And that is, you'll find it on the front page of your reference table. So if you go get your reference table out real quick, or if you can't find it, you know, people asked me the other day, you can always just search New York physics reference table, and it'll come up right here. And so you can bring it right here, and I can scroll down. Now right here, guys, you'll notice right here you have the approximate coefficients of friction. Now notice, guys, each one of them is between two surfaces, rubber on concrete, and also sometimes it tells you if it's wet or dry, because that's very important too. And this is why it's dangerous to drive in the rain, because friction decreases. Now you may say, well, friction decreases, it should make it easier to travel, but it also makes it harder to stop. Okay, guys, so this is just some food for thought. Thanks for listening.